associated with Watergen. Uh, yeah, can you hear me?
Yeah.
Yeah, yeah.
Yes.
That's something very interesting for all our members and fraternity. So, I'm moving forward with presenting, introduction with Dr. Yaron Aviv, who is associated with Watergen as R&D manager, and his company mainly targets global water crisis, water hazards, regulations, and challenges lay ahead. Why this is 1 minute? Mm, yeah, so there is some disturbance I'm facing on my screen. Okay, sorry. Up to date challenges lay ahead and up to date achievements. So Dr. Yaron holds a PhD in biochemistry from Ben Gurion University, Israel, in 2011. And then he finished his postdoc research at the Institute of Cardiovascular Sciences at St. Boniface General Hospital Research Center, Canada, and got an award in the honor of a young scientist investigator in 2010. From 2011 to 2016 as a laboratory manager at the Institute of Microbiology for Food and Consumer Goods. Yaron experience with analyzing and applying data from various fields in drinks industries. Before 2017 from 2017 as the R&D water technology manager in Watergen, he takes the central part in planning and carrying AWG's projects, ensuring Watergen compliance with the highest international water standards, laboratory facilities, and a regulatory division which is tasked with his professional experience in applied research are being applied at Watergen to continue developing water from air technology solutions. So I welcome Dr. Aviv in this webinar. Over to you, Dr. Aviv. And before you start, I request all of my participants to post your questions in the chat box so that we can take up those questions in the end. And over to Dr. Yaron.
Thank you so much. Appreciate that. Nice talk, nice speak. So my name is Yaron Aviv. I'm R&D manager of water technologies at Watergen company. Hopefully you are all safe and sound. And it is my pleasure to present here our vision regarding water from air as a new emerging source for drinking water. So Watergen was established back in 2009 with the vision to provide water from air as accessible commodity for millions around the globe. Since then, we have developed different devices from small home and offices to a large-scale machines that generates up to 5,000 liters a day. So importantly, our vapor compression, which is the heart of the unit, is patented. And it is, so let's move on to the presentation. It is well understood that water scarcity has become an alarming issue in the recent years. And this is the main reason we are all here today. Okay, so from the outer space, the Earth looks like a blue planet because most of its surface is covered by water. Only 3% of that water is fresh, however. Less than quarter of that fresh water is accessible for human consumption. And it is very unfortunate that third big ground reservoirs are distressed. And actually, it is estimated that by 2025, 2/3 of the worldwide population is expected to live in a region with water scarcity. Hence, alternative water sources and innovative technologies for drinking water production are sought in this presentation. So this leads me to the presentation objectives. We will overview water sources, and of course, we will talk about water from the air, potential hazard in the air, on the ground reservoirs, regulatory aspects associated with AWG. We will speak generally about different methods of AWG technologies, and finally, we will talk about customizing water upon demand. So let's briefly scan the conventional sources of water we all take advantage of. And you probably know that 1.7 million of people die annually of water-related disease, and this is very unfortunate information. And this finding is not of surprise given the problem we addressed just by now. And as we speak, natural sources of potable water are mainly include mineral, spring, and artesian water. And as we already agreed that these sources are distressed, in the last 25 years, people increasingly rely on purified, desalinated, deionized water as their source. And in fact, these sources are becoming controversial as a result of carbon fingerprint and salination of ground sources. Still, including purified water as an additional source, a third of the world nowadays consume unsafe water. So what else can be done? So the solution relies in the atmosphere. This available and important source is part of the hydrologic cycle that we can use for humankind benefit. So to better understand this part of water from air, let's first talk about the magical hydrologic cycle. Sorry. Okay. The hydrologic cycle is the continuous movement of water in the air, on the surface, and below the earth. So this dynamic process allows at any time point, some estimation says that it's 13 cubic kilometers of water at a given time point. So given the balance between the water above and the water below, we can get a steady state in our atmosphere of renewable fresh water. Please pay attention also to the fact that the earth acts as a gigantic distiller, and therefore it's obvious that the amount of contaminations in the humid air is low in several orders of magnitudes when compared to the pollution coming from the surface and ground reservoirs that continue to accumulate contaminations. So allow me to highlight these three important aspects before we go. So advantages of atmospheric water are especially in low accumulation of pollutants. This is a cleaner source. It's a renewable source and no effect on other water sources on the ground. So from strategical point of view, several years ago, Watergen globally surveyed the need. I'm sorry, do you hear background noises? Okay. Okay.
Yeah, we can hear you. We can hear you, no problem.
But there is some interference in the background of my noise. Never mind. From the strategic point of view, several years ago, as I just said, Watergen globally surveyed the needs for AWG. The surveys also included technological gaps between different water sources. So this table show here very narrow view and part of the big picture when we compared the atmospheric water generator versus tap and surface municipal RO desalination and distillation. Although the price per liter in AWGs is mid to maybe a little bit high relatively to the other, there are other aspects that are more important in this case, which is the pollution, water quality, and maintenance. So the pollution is low, of course, while producing this device and while this device is working. And in case of tap, RO, and distillation, it is also low. However, keep in mind that there is a lot of infrastructure surrounding this whole case, and it leaves also carbon fingerprint. And in addition to that, there is RO desalination. In RO desalination, the byproducts of greenhouse gas is relatively high in its emission. In terms of water quality, all systems are high in quality. However, it's high in quality in the other sources, especially when it goes out of the facility or the plant that treat this water. the infrastructure is the problem, because in the infrastructure you have welding, you have old pipes, you have deposits of organic materials inside, and you have deposits of byproducts of disinfectant that are administered into the system. So we see here this point as another advantage. So finally, in terms of maintenance, it is a low maintenance and a very user-friendly, while the other needs high constant monitoring, frequency replacement of frequent replacement of filters, and so on and so forth. So we scored finally we scored after the survey the advantages of AWG versus the other, and we found it very much at the top, the high top of the list. So everything is perfect, right? Well, let's think again. There are two missing parts in these puzzles that I would like to emphasize in this presentation. The first one is the potential hazard. As very little known about the route of contamination from air to water relatively to other sources, for instance, which are well defined, let's map the possibilities. So what we see here is a table showing major group of potential contaminants that are associated with water. And we have the mechanical, which include microplastic, protozoa, and so on, and bacteria, of course. And we have also chemicals, which include anionic and cationic, including heavy metals, other organic compounds. And we have the microbial part, which include viruses, bacteria, fungi, and of course also toxin related to those specific or certain bacteria. Finally, we have the organic molecules, which include volatile organic compounds, semi-volatile and total organic, and of course, aromatic hydrocarbon. All these elements are associated in general with water. We can find them seldomly in places where the infrastructure is not treated well. However, we don't know what is the fate of AWG in this case, for the reason that we are collecting water from the air. Therefore, the next mission was to locate a list of contaminants that are associated with air pollution, and we went to the list of WHO for that. And according to the WHO, we sort the major groups into, just to make it simple, we sort it into 4 major groups that we call gaseous pollutant, motor vehicle, particulate matter, and microorganisms. And just an examples for every one of them, but please pay attention to the fact that every group is talking to one another. So for instance, dust is a vehicle to carry viruses, bacteria. It also vehicle to carry volatile organic compounds. The same thing with fume, mist, and smoke. So the question that is still lying above is the understanding of the route of contaminants and its significance on potable water, which is still a conundrum in our case. So the second missing part of the puzzle is regulatory aspect that ultimately depend on this part that we just mentioned here. While much knowledge is known about municipal system, we can establish our base on municipal and adopt or sort out different aspects as our knowledge and experience grows. For example, a good example coming from Municipal Authority of Ontario, Canada, showing the components of the Ontario's drinking water protection framework. And they all work together to protect drinking water. However, when dealing with AWGs, we have to define this framework differently with special attention on this major 4 group as far as I see it, which is water safety related component that are finally monitored by the users, the endpoint user. And just as an example, as we just mentioned the contaminants, I believe that many of contaminants, and based on our knowledge that we have today, some of the contaminants that are very likely to have in infrastructure of municipal or other systems is not necessarily related with AWGs. And we will discuss about it later on. And of course, there must be a real-time alert in the system to provide the user the alarming issues that may appear. The next step was to map the whole world um, in terms of standards. And generally, most of countries lines up their water safety standard with international common standard, and still some variations can be found locally. This is very important thing because this finding can give us the perspective about what contaminants are more abundant in certain area. And therefore we map the whole globe with a specification to the area where between the latitudes that allow water generation in the summer and of course in the winter. We also paid attention to the places that are too arid for AWG's activities. So please note that our attention was initially given to places that AWG works. And finally, we ended up with a list of stringent requirement we call Watergen requirements, okay, that serves as a thumb rule to approve our devices. And in addition, a lot of our attention was given to the pollution because of pollution in the air, I mean, because of different behavior of contaminations in the ground versus the humid air. And for instance, as an example, just to emphasize what I mean, for instance, heavy metals such as lead appear in different metallic or ionic forms on the ground versus organic compounds in the air. So the solubility is different, and this must be considered when thinking about regulation in case of AWGs. Another issue is the bacteria versus bacteria on ground reservoir and bacteria in the air or other microorganisms in general. So they may be significantly different and versatile on the ground versus the air. Therefore, it should be taken into account. For instance, let's say we are just now addressing the demanding for tests. We have to think what is the significant microorganism that best represent the conditions for AWGs as an indicator. And finally, as we just said before, contaminants concentrations are completely different. There are two another important issues or aspects that associated with air water is the water corrosiveness, because the water is almost distilled and many elements are missing in this water, and the pH of this water is relatively acid. So as a result of no minerals, minerals is also have to be considered for the addition into the system. So we had I'm very pleased to say that we had the privilege to assist the APMO in generating the ASSE 1090, which is the first standard that in the world that deals with AWGs, and its scope is specific on this subject, and this standard was approved by ANSI and published last year. Closer look on the standard shows revealed and the up-to-date knowledge related with AWGs and water safety, focusing on highly relevant aspects. And we can see here many aspects associated with safety, safety parts, health effect, aesthetic effect, and many other. But let me please outline three relevant aspects that are new in this standard, and they include oils, because most of the technology is based its knowledge on and mechanics on heat exchanger. These heat exchangers are coming from the metal industry, and they very likely to have oil residues that in some places or cases can be toxic or unsafe for consuming. Another issue that was addressed in this standard is the corrosivity, because the water is corrosive for as long as the machine is working. Therefore, this corrosiveness may affect some wetted part in the list of these parts of the machines. Therefore, these devices must be tested carefully under certain conditions of acidity to approve their use in the AWG machine. The last thing, and a very interesting one, is the energy efficiency, which set by the standard to 3 liters per kilowatt hour under subjected to 60% of humidity and 27.5 degrees centigrade. So the last thing I mentioned, the energy efficiency, is the sorry, is in this case the energy consumption. In this case of energy consumption, many researchers believe that energy consumption is the Achilles heel of the system. However, I'm not think this is really true in this case, because there are close look in the literature revealed a progressive work done by Ben Guido and his group, which demonstrated, and we see here the psychometric chart of humidity versus temperature versus efficiency of energy consumption, which demonstrated the moisture harvesting. They demonstrated the moisture harvesting index, as we see here in the rainbow colored lines. And this index is an important tool for assessing the energy requirements of active cooling AWGs. So they set the limit for 0.3, which is here in the green arrow, while the ASSE set the limit to 0.5 under different conditions. So the different conditions are more friendly to the manufacturer to still fill the gap and to keep up with the standard. Another important issue was addressed in their work of this group of Ben Guido and his friends, related with the smart management of energy. So to be efficient in water production, AWG must work according to the work, and this is seems to be very reasonable, to work in different interval depending on location and times. And we can see here the fraction of favorable time to AWG for energy consumption and still be efficient. And the gray indicate the fraction of unfavorable time. Altogether, this also raised the question when we deals with standard. This means that the system will have to encounter many stagnation points. And the way to treat the water in order to prevent biofouling is very crucial when designing such a device. And this should be also addressed when thinking about the standards associated with water safety. So with this knowledge in our toolbox, let's move on to the principle to consider in planning AWGs. And I'm sorry, you probably got my presentation, and I have some differences that I made along the way before today. So to better understand what are the principles, let's take a look on the big word that we call AWGs, which is atmospheric water generator. So in general, from this picture, we understand that there are many methods to harvest humid air. Some are passive, while others utilize energy. Some use smart materials, and some are very natural sources that people use for thousands of years. So the technologies of AWGs can be roughly subdivided into three major groups. We see the direct harvesting, vapor concentration, and integrated system. Every one of those includes many aspects. However, above all these nice names, only vapor compression is efficient in large scales, mass production, and practically in case of marketing. So let's make some order in these whole beautiful names. So therefore, this is another different slide I added to the presentation. So I organized main methods but the main methods by its yield of water production, starting from the vapor compression, which is the more dominant one among the rest, and the more accessible in terms of marketing, but given and also takes the most amounts of energy as input. The other methods like thermoelectric cooling, which also includes energy input, its yield is much less than in amount comparing to vapor compression. Fog and mesh panels are used in strict area that are specifically specific with climate. And again, they still depend on climate conditions. So there is no assurance for getting water constantly. The absorber is another new word, including such as halide salts, metal organic framework, what that we call MOFs, zolit, and other materials. There are very smart materials. They are all under processing and investigation, but their yield is relatively low. But it's a very reliable option that this absorber may be found in the future as combined with vapor compressions. And of course, natural structures that are not commercially available or something that we can use in the market. So in the future, we predict that water production efficiency will grow and energy input should be at least remain the same or hopefully will be less. And the question is, when we understand that vapor compression is the major potential that we have currently at the market, is how do we tailor the AWG criteria correctly? And with this understanding, let's move on to the criteria related with vapor compression design. So we collected several aspects that talks to each other again here, which is the environmental condition that must be taken into account the design of the system, such as air temperature, relative humidity, and the dew temperature obtained from the given environmental condition. And this is also determinant that is affected and affect the production planning that will carry out according to available weather, as exactly what the group of Ben Guido showed in their work. They're all dictated by the safety. And some part of it we already mentioned, the approved raw materials, which must be cleaned from harmful chemicals. All matrices must comply with corrosive water. Safe production environment is a very important issue for keeping the machine safe. As we know that most of the machine will be stored for many times, sometimes for long periods, and some biofilm or other problem can grow in the machines. Therefore, safety environment for manufacturing is very important. And of course, real-time alert to alert the user that something went wrong. And of course, just as an example, we have also limitations of the mode itself of vapor compression, because under 9 degrees, it is not sensible to produce water for the reason that the gas may freeze and there is not much water in the air. So another aspect of the principle is the regulatory adaptation. Oops, sorry, yeah. So given that we already agreed that the basis for the safety of the device has to include the ANSI 1090 53 for health effect and the 42 for anesthetic effect and NSF 61, of course, there are some differentiations between the, let's say, conventional systems than what we expect in the future as our knowledge will grow. So in case of material safety, we know that according to the ASSC, oil is an important issue. Also, corrosive water and the extraction of water when we test the devices is very important. And in case of filtration, most of the conventional filtration nowadays are based on municipal water or other systems. And this is not necessarily addressing the problem given when we have the device work in natural environment and affected also by human-related byproduct. So in case of natural sources, there are NOx and SOx and heavy metal and organic molecules. And of course, in the human surrounding, there are pesticides, herbicides, and heavy metal and so on. So the understanding of as we addressed in the question before, what is the portion from that element that goes to the water or goes to the machine and how it handle it is very important. Therefore, special filter must be designed based on the research that us and other people do all over the world. And storage, as work of Ben Guido showed that multiple stagnations can occur in a certain amount of times. Biofouling is another issue to deal with and to keep the systems, in order to keep the system safe. Two important other things that I would like to address are sanitation and remineralization and pH adjustment. In case of sanitation, because this system is standalone and not constantly fed by disinfectant as municipal systems do, this sanitation is a vital part in maintaining the machine and keep the system safe. And it's very easy to get rid of the sanitizers because this system is standalone after all. And another issue is the remineralization and pH adjustment that we will discuss on the next slide. So given that AWGs harvest distilled like water, adjusting the water to human physiology that is not only presented by odor or taste, but also, and more importantly, by cellular function of our body, it is very crucial to add certain minerals. And for instance, calcium can be added by using a bicarbonate cartridge in order to adjust pH. And I believe in the future there will be other elements that will be available for adding and on demand, of course, such as magnesium and other elements that we can see on bottled water. So eventually adjusting the pH to 6.5, between 6.5 to 8.5 according to the standard is very important in this case. The other thing that I would like to address is the sanitation, which is affected by atmospheric and dynamic environment. Let's say the differences in the air in rural country or industrial zone or by the ocean or other places or urbanic area may completely change the map or the flora or of molds, spore-forming bacteria, viruses, and of course there are many differences in organic compounds that may be localized in the air that eventually maybe and potentially can go into the device and finally affect also sanitation by hindering it. Byproduct is another issue that is most important in case of municipal water. However, when we sanitize and just mention the standalone device, it is very easy to rinse out the device and get rid of all these byproducts that normally can accumulate inside systems that work, such as infrastructure that works, municipal infrastructure that works for several years and kept fed with the sanitizers. And there's always behind the corner the unknown that we are seeking and looking for to keep our devices and all AWGs safe. So the next issue is the research, and research is very powerful tool in a new product development. In order to minimize, sorry, the unknowns, as we said, as much as we can in our in-house research, together with collaboration with academic-based research, we significantly accelerate our understanding the AWG function in different environments. So these two articles were recently published by our group, showing different elements that were localized in the surrounding of the device. And we are working hard on developing a specific purification system that suits the knowledge that we get from these investigations. And microbial investigation is another important issue, just to emphasize. And we have here also a machine that came from Mumbai, India, in Israel, that we collected water from the internal part of the machine before filtering the water. So I'm sorry, no. The devices were collected as an outdoor or indoor devices from different places all over the world, and also in places in Israel, and we can see that. And I'm very pleased to say that we couldn't see any significant pathogens such as Salmonella, Legionella, Listeria, or other harmful pathogens in the device. So it means that they are less likely to have in the humid air. And this is also emphasize very important aspects that we know how to handle when we design a device. So I would like to summarize this presentation now and talk on two different levels. The first level is the environment, the other one is the device itself. Environmentally speaking, the devices are eco-friendly, utilize green energy. This aspect will grow, I believe, much more in the future. And it is the source itself, the humid air, is unlimited and renewable source. The air source is much cleaner. We all understand that. The device itself is a safe platform. It's easy to install. Water transportation is not needed because it's standalone and put in place on site. The infrastructure is it's infrastructure independent, of course, although some customers prefer to add some local infrastructure for, let's say, fountains and other storage tanks. This is also possible. And it's low maintenance and mobile. So I would like to thank you for listening, and I believe the next part would be questions.
So thank you, Dr. Aviv. And it was a wonderful and very lucid presentation. I think you captured very nicely each and almost every aspect of air to water, which is, I know that my members have fairly they have a knowledge, but I don't think such a deep knowledge they have on this subject. Before I open the, this forum for the discussion, I would like to have a question is that, uh, how different sizes of AWGs that you have available, and so how this is really, so this AWGs, like primarily my member companies, they are uh, they are the, residential purification systems, most of them. So probably they are interested to know about this, and also maybe some commercial also the system. So can you throw some light on this?
Yeah, we have different panel of systems starting from home and offices, Jenny 3, which generate up to 30 liters a day. It also have the option for cold and hot water for small offices, for small home and offices. Also, we have the Gen 350 and the modified version of that, which capable of generating somewhere between 350 to 600 liters per day, and it also equipped with a water tank inside the system. The large scale is another device which is a little bit different in the method, but works and generate up to 5,000 liters a day, as I mentioned. And more importantly, the fact that the Gen 350 is one more important thing to say about the Gen 350 is that it can be mounted with generator RV to head assistance in a catastrophe zone or military reasons and things like that. So filtration-wise speaking, every mode of system is working more or less the same with some alternation and variations. And we also capable of customize specifically to area. For instance, if there are some problems of arsenic near volcanoes, uh, we have other solutions for specific cases.
Thanks, Dr. Aviv. I think a couple of questions are coming up. It looks like Badrinath, CEO, Micropore, Bangalore. Is this technology transfer is available? Uh, what is exactly the questions? Technology transfer available means what? Uh, Satyanarayan, can you ask directly? Anjali, can you make him available?
We have a huge area in Malur industrial area. Is this technology can be implemented? What will be the cost of the project?
You are asking for a cost?
Yeah, project cost.
So my suggestion would be that this is a neutral platform. So we will
Okay.
post it. We will post it. The email IDs, so you can directly write to Dr. Aviv on this, because this platform is not to discuss any sales, pricing, and all. And you are free
Okay.
to write to him. Get on a conference call with him on a Zoom or similar platform. So you are open to do that. No problem. Thanks, Satnam.
Sure. Thank you.
Okay,
Thank
then
you.
next question is Ajay Popat. What is the energy consumption in terms of kilowatt hour per meter cube? This is the first question. I think you are also, you can see this question, isn't it? We can't hear you.
Yaron, you are on mute, actually.
You are on mute.
I didn't do anything. I'm sorry.
Can you
So
see the questions?
no, I don't see it now. I saw it before, but it was very fast eliminated from
Go
my
to the
screen.
go to the chat box. You see the Ajay Popat is asking two questions to you. Otherwise, I can help you out. What are the questions?
Let's see. What is the power requirement per liter
Yes.
for your small system and the largest one too? The small system is 300, I think. I'm not familiar exactly with the physics of the system, okay? I'm scientist here. On water technologies, there are scientists in the R&D in the part of the engineering, but I can transfer the question. I can roughly say that it is somewhere around 300 watt hour per liter.
Okay.
In the small unit.
Yeah, so another question from Ajay Popat is that considering the poor quality in India, what traditional precaution system features needs to be incorporated? Is specific to India.
I don't see the question again. I'm
You
sorry.
can just go a little up.
Okay.
Ajay Popat to everyone.
Oh, what is the energy consumption in terms of kilowatt hour?
Per meter cube.
I'm not sure. I don't know this question. I can check that.
Okay, no problem.
Considering poor air quality in India, what additional percussion system feature need to be incorporated? India-wise, we had the machine in Mumbai for 6 months, and we tested the water, and we didn't see any deviation from the standards. So perhaps there are other, let's say, industrial or heavy industry zones that they were not tested yet, but it is very important. First of all, I must say that all machines must be localized whenever people can live. Okay, it doesn't make any sense to put in a chemical where you have a lot of chemicals in the air such a device. So basically, in an urban area such as Mumbai, we didn't see any deviations from the water.
Okay, then Cost of production, anyway, we said that that will be taken care of individually. Uh, then Ramakrishnan, the energy consumption of 300 WH per liter for favorable condition, high dew point, or unfavorable conditions.
Again, I'm sorry. I don't see what's the question.
Ramakrishnan, Mr. Ramakrishnan to everyone.
It's in the top. I'm sorry, I don't see it.
No, just little above the top.
Well, what he says is that the figure of 300 watt power per liter, is it for the ideal dew point condition, or is it?
Yeah. Yes.
Yeah.
Yes. Again, guide me to the question again. I'm sorry.
See the question. I don't know you can see or not. The question is that what is the dew point? What is
What
the
is the
high
dew
dew
point?
point?
What is the ideal dew point?
I think we have in our R&D of engineering chart showing the exact dew point. I cannot address you this answer correctly. Okay.
Okay.
It's relatively, of course, dependent on humidity and temperature. So it's depending.
All right. So couple of questions. I think somebody asked some pictures of the product. So I suggest that you can go through the website, and that will help you out. And Watergen website, which we will share in the WhatsApp group, so you can see those different sites. I hope that all that is captured in the website,
Yeah.
all the information.
Yeah, the whole information is in the website, including frequently asked questions. And I see some of the questions that are associated with the question that are addressed there. But if you have any other questions, it is very, I'm very pleased to be for you there in the email.
Yeah, looks like is that yes, I think uh, we have I think some questions which can be addressed there. So what we suggest is at this moment is that I think we are close to almost noon now, almost. So
Lunchtime.
last question, maybe how do you control the pH?
How do you control the pH? Good questions. As I just said, we introduce in our systems mineralizator cartridge, mostly made of calcium carbonate. We are working on improving this device. Although it's working very nicely and it's adjusting the pH very easily, we are working on improving the inputs of calcium inside this cartridge and to improve the solubility of the calcium inside it.
Yes, I think we are close to 12. I know that it's gone almost like 1 hour 15 minutes for you.
Yeah.
So
I have water here.
Early.
Water from the machine.
Water from the machine. Before we adjourn this meeting, so I wanted to bring to the attention of all our members fraternity is that we will post this video in the WhatsApp group. We will give the email ID of you know uh, I think here she has given already in the group. Looks like in the chat Anjali has shared your email ID and a website, so people can reach out to you for all the cost, the number of products, what it works, temperature, pressure, or any technical details on small, medium, large systems and whatever. So I wanted them, offline they can work with your team to get all the answers, for their own knowledge as well as their own business purposes. Okay.
Yeah, no problem. We
So
will be here for you.
So with that, a big thanks to Dr. Aviv and also
Thank you.
staffs and all our members who have attended this meeting. So we look forward to have some more meetings in future in this similar line. And also, Dr. Aviv, if you think about anything in a much more technical thing, if you want to present to our group, which will be a little bit more technical, and they wanted to understand in much more details, we welcome you. You know,
Thank you so much. Thank you
provide
so
all
much.
the-
Appreciate that. I really enjoyed talking to you today. Thank you.
Yeah. So with this, I'm going to adjourn this webinar. Take care, stay safe and healthy. Bye.
Yeah, you too, guys. Thank you. Keep safe.
Thank you,
Bye
Doctor.
bye.
Bye.
Bye bye.
Thank you all. Bye.